All right, in this video, we're going to cover five medians and altitudes in triangles. First off, what's a median? It's a line segment that joins a midpoint of the opposite side to a vertex. So here we can see we have one median. Now remember, every triangle has three of them. So here we just have one. How do I know that this is marked as a median? I see that O has been marked as a midpoint, right? So we see these markings, these tick marks, they tell us that O is a midpoint, therefore this OL is a median. So segment OL is a median. That leads us to our next point of concurrency. When all three medians meet, or where they meet, is known as the centroid. And the centroid is from the midpoint of the opposite side, 1/3 the length of the median. From the vertex of the triangle to the centroid is 2/3 the length of the median. It's also the balance point of the triangle. So if you were to cut out the triangle and balance it on like a tip of a pencil, it would balance there and wouldn't slide off the tip. This then lends us to a particular formula known as the centroid formula. And with the centroid formula, as with most formulas, we have to define some pieces here. So I'm going to highlight a median. So we'll take a look at this particular median and define some pieces to it. We have what we call the short piece. Right? That's always going to be from the midpoint to the centroid. And we have a long piece. That's always going to be from the centroid to the vertex. Right? So every one of these medians has a short and a long piece. And that's going to define our formula here. So the centroid formula is short over 1 equals long over 2 equals median over 3. So they are also always in this particular ratio or proportion to each other. The next piece of the triangle that we have is the altitude. Again, that's from the vertex. It is directly perpendicular to the opposite side. Every triangle has 3 altitudes. And an altitude can be inside, outside, or a side of a triangle. So in this picture, we can see some examples of altitudes. Right? Each red segment here is an altitude of the triangle. And we can see an altitude, again, can be outside. And there isn't just one. Actually, every triangle, each vertex has an altitude assigned to it. The intersection of every altitude is the orthocenter. So the point of concurrency of the altitudes. Again, an orthocenter can be inside, outside, or on a triangle. We can see some examples of where an orthocenter could be. So in this triangle here, we can see the orthocenter is in the triangle. It is marked with perpendicular, or perpendicular to the side. So usually, whenever you're looking for an orthocenter, you're just looking for these boxes, right? And then where those altitudes then intersect hint us towards it. So in this particular triangle, the orthocenter is here, is on the triangle. Here, the orthocenter is actually outside. And you'll notice like this is an obtuse triangle, and some of the altitudes are outside for an obtuse triangle, which then leads us to an orthocenter outside of the triangle. So let's do some examples. Which point of concurrency is this particular P point showing us? So we now have all points of concurrency. It could be the circumcenter, incenter, centroid, or orthocenter. So I know it's not the circumcenter because that's the perpendicular bisectors. I don't see any of these. I see them perpendicular, but I don't see them also bisecting here. So not the circumcenter. That's out. If it's an incenter, I would see the angles being bisected. I don't see any of the angles marked as bisected. So incenter is out. Centroid, remember, emphasizes the midpoints of each side. I don't see any midpoint markings on any of the sides. Centroid is out. Now, just to make sure it's an orthocenter, I need to make sure that I see the perpendicular marks, which I do, and that those segments are going to the opposite corners. Yep. So this is definitely an orthocenter. All right, taking a look over here, classifying the point of concurrency shown. So if I follow this list again, it could be a circumcenter. So again, I don't see any perpendicular, but I do see bisecting. So I know R is a midpoint and P is a midpoint. So immediately I know circumcenter is out. In-center is out because I don't see the angles bisected. Centroid, I do see that R is a midpoint and P is a midpoint, and P is connecting to the opposite corner. R is connecting to the opposite corner. Looks like it's a centroid then to me. So centroid is our choice. Taking a look over here, which point is the orthocenter? So orthocenter, we're looking for perpendicular box. So I see a box right here. Right, here's my box. I'm going to follow that segment. Goes to the opposite corner. Good. I see another box here at E. All right, and we're going to follow that. See if it goes to the opposite corner. It does. Their intersection verifies where that orthocenter is. So point H is the orthocenter. Here we have, let's see, I, K, L are midpoints of sides of triangle HJL. If JM is 18, find JN and NM. All right, so first off, let's label some of these things so we can see them on the triangle here. So JM is 18. I'm going to use purple here. We need to figure out what JN and NM are. Oh, and we should also make a note that IKL are midpoints. So let's mark them in the picture as midpoints. What does that make N? Because these are all medians, N is a centroid. That tells me then I'm going to want to use the centroid formula. Okay, so we have our median already defined. It's JM. We need to figure out what the short and long are. Short, you can always look and depend on the picture here because it has to be drawn to some sort of scale. I cannot draw the short in any way that would look longer than the long. So let's label. And then substitute these into our formula. We know that the short piece is NM, and we know that the long piece is JN. So, and we also know that the median, which is JM, is 18. So let's focus in on this formula. In order to solve these two measures here, right, we've got to use this completed fraction. In this formula, you will always, as a level 2, always see some sort of completed fraction to help you solve the other missing pieces here. All right, so let's solve for NM first. So I'm going to rewrite the proportion, and then we will cross multiply and solve. So here I'm going to cross multiply. 18 equals 3NM. Divide by 3 both sides. So we get NM equals 6. To figure out what JN is, we're going to follow the same process and set it equal to this completed fraction and cross multiply to solve. So now that we have it set up, we're going to cross multiply and solve what JN is. Now as a check, remember that these two values should add up to be the median. And 6 plus 12 equals 18. That checks out because that was the length of our median. Let's take a look here. Here they just explicitly tell us H is the centroid. So let's mark it quickly as the centroid. That means putting in our midpoint marks for each side. And then they tell us to find X and Y. So we'll find X first. I'll notice that X belongs to this particular median. And in that median, we have the short piece and we have the long piece. So because we know we're working with the centroid, let's take the centroid formula out here. And when setting this one up, I noticed that the short is 2x minus 1. The long is 3x plus 6. And I don't really have any information about explicitly what is the median. So I'm going to leave it as BF here. So now I can take a look at the formula. Got all these pieces. Right now I'm thinking, right, I don't have a complete fraction here, right? This is why this is kind of like a level 3 to almost a level 4 type problem. This guy's not going to be so useful to us because our goal is to solve for x. We'll notice that both these fractions have an x in them. So now they're already set up as an equality statement. I'm going to cut them out and solve this equation. So cross multiply and then solve for x. So we got x equal to 8. Next, we have to figure out what y is. So taking a look at this particular picture, I see y is part of this particular median, which then has its own separate long and short. And because it's part of a centroid, I know I'm going to have to use the centroid formula here. So the short, I don't have any numbers corresponding to that particular short, so I'm just going to leave it as DH then. Long, I see that it's 2y plus 8. And then median, I don't see anything here, so I'm going to leave it as DC. So I don't have another thing to solve it for. Let's double check the instructions to see if there's any information that we missed. H is the centroid of ABC, and DC equals 5y minus 16. So really, I can substitute this DC with 5y minus 16. Now that allows me to eliminate this particular fraction and then work with only these two to solve for y, right? Because that's what I'm looking for here. So I'm going to copy that, set it separate, solve. Remember, you're going to have to cross multiply here. So y turns out to be 14 for this problem. So again, I would warn you guys, like this particular problem would be about a level 3, all right? More commonly, you would see a problem like this as your level 2. Since there's a lot of labeling and making sure that you guys follow through on a formula that's been given to you, okay? And that ends today's lesson, and make sure you complete the summary. Thank you.